So in this particular segment, we are going to solve a few questions based on matrices. And this is the first question. The matrix A is given, the matrix B is given. We have to find the matrix X such that 4A plus 6B minus 10X is equal to null matrix. So don't view this as 0. This is actually the null matrix, because when you add or subtract matrices, you always get a matrix, and therefore this is counted as a null matrix. So if I want to find the matrix X, again I will keep all the known values on one side and the unknown values on the other side. So I would say 4A plus 6 times B is equal to 10 times X. And now I should substitute the values of A and B. So that's 4 times 6 to 5 and minus 4 added with 6 times B. B would be 1, 2, minus 5 and 1 is equal to 10 times X, right? This equals 10 times X. So this equals 10X. And now I can simplify. When I have 4 times the matrix A, it means that I have to multiply each term with 4. So 4 6 are 24, 4 2s are 8, and 4 5s are 20, and 4 into minus 4 is minus 16, plus 6 times this matrix. So 6 times this matrix would be 6, 12, 6 into minus 5 is minus 30, and 6 ones are 6. This equals 10 times X, right? So now it's time to add the individual matrices. So when we add the matrices, we add the corresponding elements. So 24 plus 6 would give me 30, and 8 plus 12 would give me 20. Then I have 20 minus 30 is minus 10, and minus 16 plus 6 is also minus 10. This equals 10 times X. And therefore 1/10 of, let's write the matrix, 30 minus 10, 20 and minus 10 is equal to, this whole thing is equal to X, the matrix X. So when I have 1/10 of a matrix, it means I need to multiply each element by 1/10. So 1/10 of 30 is 3, 1/10 of 20 is 2, 1/10 of minus 10 is minus 1, and 1/10 of minus 10 is also minus 1. So this is equal to the matrix X. Therefore matrix X is 3, 2, negative 1, negative 1, and this is how we find the value of the unknown matrix. So the concepts used over here were simple multiplication of a matrix with a scalar value and addition and subtraction of matrices. So again, let me pause for a few seconds before moving on to the next question. Okay, let's pick the next question. So in this question, we have matrices P, Q, R and S given to us, and we have to find the values of PQ plus 2 times R minus 4 times S. Now the matrix PQ will be equal to the matrix P, that's minus 3, minus 2, minus 1 and 4. This matrix is multiplied by the matrix Q, which is 6 and 1, right? And what I can now do is, I can see first of all, is multiplication possible? So this matrix is a 2 by 1 matrix, 2 by 2 matrix, and this is a 2 by 1 matrix. So we notice that the number of columns in the first matrix equals the number of rows in the second matrix. And therefore this matrix is going to be a 2 by 1 matrix, right? So a 2 by 1 matrix would mean there are 2 rows and 1 column. So this is first row, first column, and this is second row, first column. So now we have to find the element first row, first column. So to find that, we take the first row, and the first column, right? So we take the first row, first column. So therefore this would be minus 3 into 6 is minus 18, and minus 2 into 1 is minus 2. And then second row, first column would be, you take the second row and again you take the first column. So it would be minus 1 into 6 is minus 6, and 1 into 4 is 4. And therefore this particular matrix becomes negative 18, negative 2, that is negative 20, and negative 6, positive 4, which is negative 2. So this is the matrix PQ. And now we have been asked to find PQ plus 2 times R minus 4 times S. So let us evaluate this. PQ plus 2 times R minus 4 times S would therefore be, PQ would be minus 20 minus 2 plus 2 times R, that's 2 times plus 2 times R is negative 4, 5, right? And minus 4 times S. So minus 4 times S is going to be 2 and 2. So this particular value is therefore negative 20, negative 20, negative 2. And then we have plus 2 gets multiplied with those individual elements. So 2 into minus 4 is minus 8, and 2 5s are 10. And then 4 gets multiplied with both the terms. So it is minus 8 and 8. So now let's combine the individual elements. So it becomes minus 20, minus 8, and then minus 8, right? So be careful with the addition subtraction. And then you have minus 2 plus 10, negative 8. And therefore the final answer is going to be negative 36, and negative 2, negative 8 is negative 10, negative 10, positive 10 is 0. And therefore the resulting matrix is negative 36 and 0, right? So this is my final answer. Again, here I use the concept of multiplication of two matrices and then addition of the different matrices, addition and subtraction, and also in 2R and 4S I had to multiply a scalar with the matrix itself. So these were the different concepts used in this problem. Let's pause for a few seconds before moving on. Yeah, let's move on to the next one. So take a look at this particular question. We have multiplication of two matrices equal to 7 minus 9. Now, if you notice matrix multiplication, here we have a 2 by 2 matrix and we have a 2 by 1 matrix here. The multiplication of these two matrices results in a 2 by 1 matrix. So when I say 2 by 1 matrix, it means that I have 2 rows and 1 column, right? So let's find the element of first row, first column, and second row, first column. Let us find the element of first row, first column. So first row, first column element would be, I would take the first row, that's 2 and 4, 2 and 4, and these two elements would be multiplied with the elements x and y. So I get, from this I get 2x. So from this I get 2x plus 4y. And now to find the second row, first column, I take the elements of the second row and the first column. So it becomes minus x plus 0 into y, that's 0y. And this has to be equal to 7 minus 9. So now this is also 2 by 1 matrix. So we know that if two matrices are equal to each other, then the corresponding element should be equal, which means 2x plus 4y is equal to 7, and the other equation is negative x equals negative 9, right? And negative x equals negative 9 implies that x is equal to positive 9. So now that x is equal to positive 9, we will substitute x equals 9. So substitute x equals 9, say in the first equation, and we get, so this is the first equation, so let's substitute x equals 9 there, and we get 2 times 9 plus 4y is equal to 7. So 18 plus 4y is equal to 7, which means 4y equals 7 minus 18, or 4y equals minus 11, and therefore y equals negative 11 upon 4. So these are the values of x and y, right? And the concept that we used in this question were equality of matrices. If two matrices are equal, then their corresponding elements are equal. And of course, matrix multiplication was another important idea that we used in this particular problem. So again, pausing for a few seconds before moving on. Okay, let's take a look at this question. We have evaluate. This is one matrix that is given to us, and this is the second matrix. And we have to multiply these two matrices, right? That is what is given to us. So first, let us figure out the order and let's see if multiplication is possible. So this matrix is a 2 by 2 matrix. The second matrix is also 2 by 2 matrix, which means multiplication is possible and the result is going to be a 2 by 2 matrix. So therefore, if it's a 2 by 2 matrix, before I multiply, let me first figure out the different values, because it looks like the elements are in terms of their trigonometric ratios. So let us simplify first. Let's look at the first matrix, 2 sine 30. So sine 30 is 2 into half, right? Sine 30 is half. Minus 2 times cos 60. Cos 60 is also half. Minus tan 45. Tan 45 is 1. And cos 0 is also 1. Right? This is the first matrix. And the second matrix is cot 45, which is 1. Cosec 30. So sine 30 is half, which means cosec 30 is 2. Cos 60 is also half, which means sec 60 is 2. And sine 90 is equal to 1, right? So now if I try to simplify these matrices, 2 into half is 1 and this is negative 1. Minus 2 into half is negative 1 and this is positive 1. Multiplied by 1, 2, 2 and 1. So now this is multiplication of two 2 by 2 matrices. So this is 2 by 2 and 2 by 2. And therefore the answer is also going to be a 2 by 2 matrix, right? So if I take a look at 2 by 2 matrix, the 2 by 2 matrix will have first row, first column, right? It will have first row, first column, first row, second column, second row, first column, and second row, second column. So now if you compute the first row, first column, you have the first row here and the first column here. So what you get is 1 into 1 is 1 and minus 1 into 2 is minus 2. Let's take a look at the first row, second column. So if I were to find the first row, second column, I would take the first row of the first matrix and second column of the second matrix. So that's going to be 1 multiplied by 2, that's 2. And minus 1 multiplied by 1 is minus 1. Now let's find the second row, first column. So for second row, first column, I will take the second row of the first matrix and first column of the second matrix. So second row, first column would be second row and first column. So this is going to be negative 1 into 1 is negative 1 and 1 into 2 is positive 2. And second row, second column will be, so I take second row of the first matrix and second column of the second matrix. So this becomes negative 1 into 2 is negative 2 and 1 into 1 is positive 1. Therefore, this is equal to 1 minus 2 is minus 1, 2 minus 1 is 1, and minus 1 plus 2 is 1, and negative 2 plus 1 is negative 1. So these are the 4 elements that we get, and therefore this is my final answer. So over here I just evaluated and simplified the trigonometric ratios, and I just used those values for multiplication, and then following the basic rules of multiplication, matrix multiplication, I was able to solve this particular problem. So again, pausing for a few seconds before moving on. Okay, moving on to the next question. In this question, we have to find a square plus b square. Matrices A and B are given to us. So a square means, by the way, a square doesn't mean you have to square all the individual elements. A square actually means you have to multiply the matrix A with itself. That means a square would be multiply 1 0 2 1 with 1 0 2 1, right? So this is a 2 by 2 matrix multiplied with a 2 by 2 matrix. The result is going to be a 2 by 2 matrix. So let's note that down. So the result is a 2 by 2 matrix. Let us write the position of the individual elements. This is first row, first column. This is first row, second column. Second row, first column, and second row, second column. So now if I were to write the individual elements, first row, first column would mean 1 0 multiplied with 1 2. So 1 1s are 1 and 0 2s are 0. So you have 1 plus 0. First row, second column would mean you take first row and second column. So 1 into 0 is 0 and 0 into 1 is 0. Then you take second row and first column. So second row and first column, 2 1s are 2 and 1 2s are 2, right? And then we have second row, second column. So second row, second column would be 2 zeros are 0 and 1 1s are 1. And therefore the result is going to be 1 0 4 1, right? So this is the value of a square. Now let's calculate the value of b square. Okay, so b square would mean, so let me just box this because this is the value of a square so that we remember it, right? This is a square. And now let us find b square. So b square is again b multiplied by b, right? B multiplied by b gives me b square. So b multiplied by b. The matrix B is 2 3 negative 1 0 multiplied with 2 3 negative 1 0, right? So now when you multiply, you have a 2 by 2 matrix. 2 by 2 matrix is first row, first column, then first row, second column, second row, first column, and second row, second column. Now first row, second column would mean first row, first row, first column would mean take the elements of first row and first column and multiply. 2 2s are 4 and 3 into minus 1 is minus 3. Then if you were to find first row, second column, what it would mean is you take elements of the first row and multiply it with the second column. So 2 3s are 6 and 3 zeros are 0. Then you take second row, first column. Second row, first column would be you take the elements of second row with the first column, right? And then you start multiplying. So now when you multiply, you get minus 1 into 2. So minus 1 into 2 is minus 2 and 0 into minus 1 is 0. So this is minus 2 plus 0. And then you have second row, second column. So second row, second column would mean that you have to take the second row of the first matrix and second column of the second matrix and then multiply, right? So it would be -1 into 3 is -3 and 0 into 0 is 0. So therefore this becomes 4 minus 3 is 1, 6 plus 0 is 6, -2 and -3. So this is actually your B square matrix. And now if you want to find A square plus B square, it would be A square is 1041 and you add it with B square. So it would be 1, 6, -2, -3. And therefore this answer would be, now I just have to add the corresponding elements. 1 plus 1 is 2, 0 plus 6 is 6, 4 plus of -2, that's 4 minus 2 which is 2, and 1 plus of -3 is 1 minus 3 which is -2. So this is the answer of A square plus B square, right? So A square meant you multiply A with itself, B square meant you multiply B with itself, and then you just add the two matrices, right? So again, pausing for a few seconds. Okay, moving on to the next question. So consider this question now. Construct a 2 by 2 matrix whose elements are Aij equals, so Aij equals half of magnitude of 2i minus 3j, right? So now that I have to construct a 2 by 2 matrix, let's understand this. A 2 by 2 matrix basically means there are going to be 2 rows and 2 columns. So this is A11. A11 means first row, first column. A12 would mean first row, second column. A21 would mean second row, first column. And then I have A22. So basically this is like the addressing system where the row number is mentioned first and the column number is mentioned the next, right? Now what is given to me? It is given that Aij is half of magnitude of 2i minus 3j. Okay, so now if I were to find A11, let's try to understand this. I have to substitute I as 1. I have to substitute I as 1 and j also as 1, right? And therefore this becomes half of magnitude of 2 times 1 minus 3 times 1, right? And that's half of 2 minus 3, which is half of magnitude of minus 1. Magnitude of minus 1 is 1, which means this is half into 1, which is half. Therefore the first element here is 1 upon 2. Now please understand the meaning of the term magnitude. Magnitude means if you get a negative answer, you just have to replace it with a positive answer, or in general magnitude, this is called the magnitude function or the modulus function. This particular function just clips off the negative values and always gives out a positive answer. So it is like we convert a vector quantity into a scalar quantity, and that's why magnitude of minus 1 is just positive 1, and therefore this answer is half. Now let's go ahead and find A12. So let me pause for a few seconds so that you understand this calculation. Okay, let's move on and let's find A12 now. So if I were to find A12, what I would be doing is, I would substitute the value of I as 1 and the value of j as 2, isn't it? So if I want A12, I would still be 1. So let me leave this I as 1. But j would be substituted as 2. So let's substitute j as 2. So in place of j, I have to write a 2, correct? So let's write it. So this is 3 times 2. So what is the change? The change is going to be, I will get 2 ones are 2 and 2 minus 3 twos are 6. Therefore, I get 2 minus 3 twos are 6. So I get 2 minus 6. And I know that 2 minus 6 is minus 4. So this becomes half of magnitude of minus 4. And magnitude of minus 4 is 4. So half of 4 is going to be 2, right? So you will notice that this value is 2, which means that this particular element that you have, A12 is equal to 2. Now let's find the value of A21. Again, let me pause for a few seconds for you to take a look at what was done. Now to find A21, what I will do is, I will substitute I as 2 and j as 1, right? So let's substitute these values. So if I want to find A21, I is substituted as 2. So that's 2 times 2 minus 3 times j is 1. So it would be 3 times, let's write it properly, 3 times 1. Right? So it would be 3 times 1. And therefore that's going to be 2 twos are 4. 4 minus 3, that's magnitude of 1. And magnitude of positive 1 is again positive 1. Therefore the answer becomes half of 1 again, right? Half of 1, which is equal to 1 by 2. So this element also turns out to be 1 by 2. And now if I want to find A22, what I will do is, I will substitute I as 2 and j also as 2. So this becomes half of magnitude of 2 times 2 minus 3 times 2, right? So this becomes half of 2 twos are 4 and 3 twos are 6. So this becomes half of magnitude of minus 2, and magnitude of minus 2 is 2, which means this is half of 2. And half of 2 is equal to 1. Therefore, the matrix that you have constructed now is half, 2, half and 1. And this is my final answer. So, a quick recap. Aij basically indicates the term in the ith row and jth column, right? And magnitude basically means that you have to ignore the negative sign wherever required, and you don't ignore the negative signs until you get the answer. So you have to compute the whole answer, and only then, if the answer is negative, you take the positive of it. So that was the other concept in this particular problem. And then if aij is given, you substitute different values of I and j to get the different elements of this matrix, and that is how you construct this particular matrix. So pausing for a minute before we move on. Okay, moving on. So in this question, the matrix X is given and f of x is a polynomial which is also given. This is capital X, whereas this is small x. So it's given that f of small x, so let's write that down. So it's given that in this question, f of small x is equal to 6x minus x square negative 9i. I is the identity matrix. They're asking me to find f of capital X. So when I have f of capital X, what it means is I have to substitute wherever I see a small x, I have to substitute it with this particular matrix. So it becomes 6 capital X minus x square minus 9i, right? Now I have to find the values of 6x and x square. I know that I is the identity matrix. So let us first find x square, okay, and then substitute it here. So x square means x multiplied by x. So let us multiply. X is 4, 1, negative 1, 2 multiplied by 4, 1, negative 1, 2. Now this is a 2 by 2 matrix. So multiplication of a 2 by 2 matrix with a 2 by 2 matrix results in a 2 by 2 matrix. This is first row, first column. This is first row, second column. This is second row, first column, and this is second row, second column. And now let's start the multiplication. First row, first column. So the way I would do it is 4 4s are 16. So I would take 16 and 1 into minus 1, right? Then I want to find first row, second column. So let me erase this and let me mark the second column. So first row, second column would mean I take the first row of the first matrix and second column of the second matrix. So 4 into 1 is 4 and 1 into 2 is 2. So this is 4 plus 2. Now I want to find second row, first column. So to find second row, first column, I take the second row. I take the elements of the second row and the first column and then I multiply. Minus 1 into 4 is minus 4 and 2 into minus 1 is minus 2. And now if I want to find second row, second column, what I would do is I would multiply the second row with the second column. So second row with second column. So it becomes negative 1 into 1 is negative 1 and 2 into 2 is 4. And therefore x square is 16 minus 1 is 15, 4 plus 2 is 6, minus 4 minus 2 is minus 6 and minus 1 plus 4 is 3, right? This becomes my x square. Therefore f of x would be 6 times x, which is 6 times 4, 1, negative 1, 2 minus x square. X square is 15, 6, negative 6, 3 minus 9 times I, right? So I know that the identity matrix is a matrix where only the diagonal elements are 1 and all the other elements are 0. So now if I were to evaluate this, this would become 6 multiplied with all elements would be 24, 6, negative 6 and 12, right? Minus 15, 6, negative 6 and 3. And then I would have minus 9 gets multiplied with all elements. That's 9, 0, 0, 9. And now let's combine the individual elements. So this would become 24 minus 15 minus 9. Then 6 minus 0. Negative 6 minus of minus 6 is plus 6 minus 0. And 12 minus 3 minus 9. And therefore the answer would be 24 minus 24 is 0. 6 minus 6 is 0. Minus 6 plus 6 is 0. And 12 minus 12 is also 0. Therefore this is a null matrix. And this is what we had to prove, right? We had to show that it is a null matrix, and I have shown that it is a null matrix. So finding the square of a matrix using matrix multiplication and then multiplying scalar with a matrix and then simple addition subtraction of matrices really helped. So let me pause for a few seconds before I move on to the next one. Okay, moving on to the next one. So in this question, the matrices A and B and C are given. And it's given that B into A is equal to C square. We have to find the values of P and Q. So what I'm going to do is, I'm going to first find B into A, right? And I'm also going to find C square. So let's first find BA. B into A, the order is important. So B first, that's 0, negative Q, 1, 0 multiplied by A, which is P 0, 0, 2. So again, this is 2 by 2 multiplication. So when I multiply this, this is going to result in a 2 by 2 matrix. So 2 by 2 matrix means I'm going to have first row, first column, first row, second column, second row, first column, and second row, second column. So first row with first column. So imagine that you are multiplying 0 into P and negative Q into 0 is 0. Then first row with second column. So 0 into 0 is 0. Minus Q into 2 is minus 2Q. So this is minus 2Q. Second row first column. 1 into P is P and 0 into 0 is 0. And second row second column. So 1 into 0 is 0. 0 into 2 is 0. So this gives me 0. So this is the value of the matrix B multiplied by A. And now let me find the matrix C square. So C square would mean C multiplied by C. So that's 2, 2, negative 2, 2 multiplied with another C. That's 2, 2, negative 2, 2. And now this is going to be again a 2 by 2 matrix, right? So this is again a 2 by 2 matrix. So now you will have first row, first column, first row, second column, second row, first column, and second row, second column. So now let's evaluate the values. So first row with first column, let us quickly start evaluating. Imagine the first row with the first column. 2 2s are 4 and minus 2 2s are minus 4. First row second column. So 2 into minus 2 is minus 4 and minus 2 into 2 is also minus 4. Second row first column. 2 2s are 4 and 4 plus 4 is 8. So we will find that later. And second row second column. So 2 into minus 2 is minus 4 and 2 into 2 is positive 4. So what is the matrix that I get? I get 0, negative 8, positive 8 and 0. So this is the matrix C square. So BA is equal to C square means what I will now get is BA is 0, BA is 0, P, negative 2Q, 0. That equals 0, negative 8, positive 8 and 0. So now you know that if two matrices are equal, you can equate the corresponding elements. So 0 and 0 are equal, 0 and 0 are equal. That means negative 2Q. So negative 2Q should be equal to negative 8, which implies that Q is equal to 4. That's the first result. And P also should be equal to 8. So this is the second result, right? Therefore, the values of P and Q are 8 and 4 respectively. So what were the concepts that we used in this problem? Matrix multiplication, of course, and then equality of matrices. So again, pausing for a few seconds before moving on to the next one. Okay, moving on to the next one. So let's take a look at this question. Matrix A and B are given. It's also given that A into B is equal to A plus B. You have to find the values of A, B and C. So let us now find the right approach to solving this problem. What I will do is I will first find the value of A into B, and I will also find A plus B, and then I'm going to equate the two matrices, right? So let's first find A into B. So to find A into B, I first need to multiply them. So let's multiply. A into B is going to be equal to 3004 multiplied by AB0C, right? So now let's multiply the two matrices. The first row, this is again a 2 by 2 matrix. So take the first row, first column and multiply. That's 3A plus 0. That's 3A. Take the first row, second column. So it is 30 multiplied by BC. That's 3B. Then second row, first column, take 0 multiplied by A. That's 0. And 4 multiplied by 0 also gives you a 0. So this element is 0. And then multiply 0, 4 with BC. So 0 into B gives you 0. 4 into C gives you 4C. So this is the value of matrix AB, right? Now it's given that this matrix AB, so it's given that this matrix AB, 3A, 3B, 0 and 4C is equal to A plus B. So what is A plus B? A plus B is 3004 plus AB 0C. So therefore what I get is 3A 3B 0 and 4C is equal to, you add the elements, you get 3 plus A, you get 0 plus B, then you get 0 plus 0 is 0, and you get 4 plus C, right? Now because the two matrices are equal, we can equate them, and therefore we get equating the corresponding elements, you will get 3A is equal to 3 plus A, which implies 2A is equal to 3, or that implies A is equal to 1.5. You can also equate 3B equal to B. So 3B equal to B will imply 2B is equal to 0, which means that B is also 0, right? So the value of A is 1.5, the value of B is 0. And then we equate 4C with 4 plus C, and therefore you get 3C is equal to 4, which means C is equal to 4 by 3. So this is how we find the values of A, B and C, right? The concepts used here were simply multiplication of matrices and of course addition of matrices, as well as the equality of matrices. So pausing for a few seconds before I move on. Okay, moving on to the next one. So in this question, the matrix A is given, which is 4, 3, 2, 5. And we have to find x and y such that a square minus xa plus yi is equal to the null matrix. So let's find a square, right? A square is a multiplied by a. Now a multiplied by a is going to be 4, 3, 2, 5 multiplied by 4, 3, 4, 3, 2, 5. So this is a 2 by 2 matrix multiplied by a 2 by 2 matrix. So we have 2 rows and 2 columns. So what are the 2 rows? So first we multiply first row with first column. So let's multiply the corresponding elements. 4 4s are 16 and 3 2s are 6. Then first row and second column. So 4 3s are 12 and 12 plus 15. Then second row first column. So 2 4s are 8 and 5 2s are 10. And second row second column. So 2 3s are 6 and 5 5s are 25. And therefore the element that I get is 16 plus 6 is 22 and 8 plus 10 is 18. 12 plus 15 is 27 and 6 plus 25 is 31, right? So this is a square. So if I were to write this particular statement, it is a square minus x multiplied by a plus yi is equal to the null matrix. Therefore, a square is 22, 27, 18, 31 minus x times a. So x times a is x times 4, 3, 2, 5 plus yi, that is y times 1, 0, 0, 1 is equal to the null matrix, which is 0, 0, 0, 0, right? So now adding the corresponding elements, we get 22. So 22 minus x into 4 is minus 4x and y into 1 is y. Then we have 27 minus x into 3 is 27 minus 3x. Then we have 18 minus x into 2 is minus 2x and y into 0 is 0. Then we have 31 minus 5 into x is minus 5x and plus y into 1 is plus y is equal to 0, 0, 0, 0, right? And now I can equate the corresponding elements. So when I equate the corresponding elements, I get, if you notice, 27 minus 3x equal to 0 will give me the value of x. So 27 minus 3x is equal to 0 gives me 3x is equal to 27, which means x is equal to 9, right? So the value of this x is 9. And now equating the y value, we get 31 minus 5x plus y is also equal to 0, which means 31 minus 5 times 9 plus y is equal to 0. 31 minus 45 is minus 14 plus y is equal to 0, which implies y is equal to 14, right? So the values of x and y are x is equal to 9 and y is equal to 14. So this is how I solved this particular question. Again, matrix multiplication, multiplication of a scalar with matrix, that was the concept used when I multiplied x with a and y with I, and then simple addition and subtraction of matrices and equality of matrices. So I think in almost all the questions I am using similar concepts. So let me again pause for a few seconds before I move on. Taking up the next question now. The matrix A is given here. We have to find A square minus 5i minus 5a minus 7i, where I is of course the identity matrix. So let's first find A square. A square would be A multiplied by A. So that's going to be 3, 1, negative 1, 2 multiplied with 3, 1, negative 1, 2. So now I will form a 2 by 2 matrix. So 2 by 2 matrix means there are 2 rows and 2 columns. So first row, first column. So 3 3s are 9 and 1 into minus 1 is minus 1. Then I have first row and second column. So 3 1s are 3 and 1 into 2 is 2. So that's 3 plus 2. Now I have to take the second row with both the columns. So let me just erase these lines quickly. Yeah. So now I take second row, first column. That means pick the second row and the first column. Minus 1 3s are minus 3. And 2 into minus 1 is minus 2. And then second row with second column. So minus 1 into 1 is minus 1. And 2 into 2 is 4. And therefore the matrix that I get is 8, 5, negative 5 and 3, right? This is the matrix A square. So now what is my expression? My expression is A square minus 5a minus 7i. So what is A square? A square is 8, 5, negative 5, 3 minus 5 times the matrix A, which is 3, 1, negative 1, 2 minus 7 times I is 1, 0, 0, 1. So what is the value that I get? I get 8, 5, negative 5, 3 and then I have minus 5 gets multiplied with this, which is 15, 5, negative 5 and 10 minus 7 times the identity matrix, which is 7, 7, 0, 0. So therefore this becomes 8, 8 minus 15 minus 7, right? And then I have 5 minus 5 minus 0, right? 5 minus 5 minus 0, that's right. And then minus 5 minus of minus 5, that's plus 5 and again minus 0. And then I have 3 minus 10, 3 minus 10 minus 7, right? And therefore the resulting matrix is, you will notice that these two terms are 0 and 3 minus 10 is minus 7 is minus 14 and 8 minus 15 is also minus 7 minus 7 is minus 14. So this is the resulting answer, which is equivalent to negative 14 times the identity matrix. Like I can pick the negative 14 out from all the, I can pick negative 14 as common from all the elements and I will be left with the identity matrix inside. So again, let me pause for a few seconds before I continue with the next question. Okay, next one. Okay, find the values of x and y if this equation holds true. So in these two matrices, I notice that a multiplication is applicable and this is simply adding the scalar quantity with a matrix. So let's multiply. This is a 2 by 2 matrix. Let's apply the rules. You have a 2 by 2 matrix here and a 2 by 1 matrix here. So the resulting matrix is again going to be a 2 by 1 matrix here. Now what is the meaning of 2 by 1? You have first row, first column and you have second row, first column, right? So if you have first row, first column, take the first row and first column. 3 into 2x is 6x and minus 2 into 1 is minus 2. Then second row, first column, minus 1 into 2x is minus 2x and 4 into 1 is 4. Plus the 2 gets multiplied with these terms. So 2 into minus 4 is minus 8 and 2 5s are 10. This is equal to 8 and 4y. So now I can add these corresponding elements. I get 6x minus 2 minus 8 and negative 2x plus 4 plus 10. This is equal to 8 and 4y. So now I can use the concepts of equality of matrices. If two matrices are equal, then their corresponding elements are equal, which means 6x minus 2 minus 8 should be equal to 8. Solving this, I get x is equal to 3, right? And negative 2x plus 4 plus 10 should be equal to 4y. So negative 2 into 3 is negative 6 plus 14 is equal to 4y, which means y is equal to 2. Therefore, the value of x is 3 and the value of y is 2. Again, over here, equality of matrices, matrix multiplication and multiplication of a matrix with scalar were the different concepts used. Let me again pause for a few seconds. Okay, moving on to the next one. So let's consider this question. In this question, two matrices are equal. That's given to us. We have to find the values of A and B. So because the two matrices are equal, I can say that their corresponding elements are equal, which means A plus B should be equal to 6 and AB should be equal to 8, right? And the reason for this is corresponding elements of equal matrices. Corresponding elements of equal matrices. So now what I will do is I will substitute. So I will say B is equal to 6 minus A, and I will substitute B. I will substitute B in the second equation. Therefore, A times 6 minus A is equal to 8, which means 6A minus A square is equal to 8, or A square minus 6A plus 8 is equal to 0. So now this is a quadratic equation. We are aware of how to solve a quadratic equation. We can use the factorization method. So we need to split the middle term. The product I want is 8 and the sum I want is minus 6, which means the numbers are negative 4 and negative 2, right? So I will split it as A square minus 4A minus 2A plus 8 is equal to 0, and A minus 4 times A, and this is minus 2 times A minus 4 is equal to 0, which means A minus 2 into A minus 4 is equal to 0. And therefore I can say that the value of A is 2 or the value of A is equal to 4. So now if A is equal to 2, I can substitute B as 6 minus A. So the value of B will be 6 minus 2, which is 4, or the value of B will be 6 minus 4, which is 2. And therefore the values of A are either 2 or 4, and the corresponding values of B are 4 or 2. And that makes a lot of sense because 2 and 4 are those numbers which add up to 6 and have a product of 8. So in this particular question, equality of the corresponding elements and of course solving a quadratic equation helped me arrive at the answer. So let me pause for a few seconds before I conclude today's session. I hope you understood the problems of matrices that were solved in the session today.